So it's 5 o'clock here, Central European Time, 4 o'clock UTC. Ready for session 2, DNSOP working group. In the agenda, there was some, we mentioned the chairs update, but normally we have 2 chairs updates, but then with meetings apart on different days. So we skipped that. We proceed directly with the next draft presentation, still working group business. The draft DNSOP Avoid Fragmentation by Mr. Fujiwara and Paul Vixie. Suzanne, are there other, maybe before we start, other procedural, organizational things to share?
I don't think so. I think we're up to date. Yeah, I think we're good. Thanks.
Good. I think still see people joining the room.
Yeah, it might be a good idea to give them another.
Maybe another minute. Let's do that. Yeah. Let's do that. To the room, we decided to wait for 1 or 2 minutes before we start with the presentation, as we still see people joining the room at 5 o'clock Central European Time. So we'll start in 30 seconds, something like that. Good.
Yeah, I think as soon as we get
let's start. Yeah, I'm following the chat.
People are sorted. We can
become nervous now. Yeah. Please, Mr. Fujiwari, please go ahead. You can start the presentation.
Can you hear me?
Yeah, excellent.
Thank you. This is Kazunori Fujiwara. I will talk about draft IETF DNSOP avoid fragmentation, fragmentation avoidance in DNS. Next slide, please. These are updates from last IETF meeting. We submitted 03 November 23 last year. 03 includes proposed changes at last IETF meeting, and we submitted 04 February 22 this year. Therefore, we added reference to Jeff Houston's presentation measuring dense flag day 2020 at OARC 34, and we changed it to use default maximum DNS UDP payload size instead of default PassMT value. And we added text about how to calculate maximum DNS UDP payload size for each destination from the PassMT discovery result, and added text about the server's PassMTU to the internet and how to calculate the DNS server's default maximum DNS UDP payload size. Next slide, please. These are updates of recommendation section. Blue part is a change at 03. If the UDP responder detects immediate error that the UDP packet cannot be sent beyond the passMT size, e-message size, the UDP responder may recreate response packets fit in passMT size or TCBit set. And red part is changes at 04. If the passMT discovery failure is impossible, UDP responders should compose UDP responses that result in IP packets that do not exceed the default maximum DNS UDP payload size described in section 3.3. And how to calculate, then calculate their maximum DNS UDP payload size as the reported passMTU minus version 4 version 6 header size 20 or 40 minus UDP header size. If the passMT discovery failed or is impossible, use the default maximum DNS UDP payload size described in section 3.3. And UDP responders should use the requester's maximum DNS UDP payload size as the calculated or the default maximum DNS UDP payload size. Next slide, please. These are changes about default maximum DNS UDP payload size. This section was default passMT value. And default maximum UDP payload size for IP version 6 is XXXX and IP version 4 is XXXX. Please choose good values before or after working group last call. And we added how to measure and how to generate good maximum DNS UDP payload size. Operators of DNS servers should measure their passMT to well-known locations on the internet, such as A2M root servers net or A2M GTL servers net, at setting up the servers and or periodically. And the smallest value of passMTU is the server's passMTU to the internet. The server's maximum DNS UDP payload size for IP version 4 version 6 is the reported passMTU minus version 4 version 6 header size 20 or 40 minus UDP header size 8. Next slide, please. Please choose the value and review. Please choose good default maximum DNS UDP payload size. Currently, there are 4 candidates. RC4035 specified 2020 as minimal value, and DNS flag day to 2020 proposed 1232. And many access line case 1400 may be good value. And Jeff Houston's measuring DNS flag day 2020 proposed 1472 for IP version 4 and 1452 for IP version 6. Please choose good value and please review. That's all. Please comment.
Thank you. Any questions from the room? Comments? Paul, please go ahead.
Hi, super briefly, because I'm not a person who tries to deal with any of this, but this last slide indicates that we are not going to be able to choose a good value. I mean, there is a vast range between 1232 and 1500.
Yeah. Indeed. We see values from DNS flag day, which has been determined by the open source software developers or by the DNS software developers. Also from operational practice, maybe someone of the implementers can comment on that. There has been measurements, like Jeff. And how can we come to a consensus here in the working group? Please go ahead, Puneet.
Hi.
Hi.
So speaking from the experience with Google Public DNS, we implemented Flag Day with a value of 1400 for both V4 and V6, and it has worked. It has worked very well, meaning we are still seeing some issues which we are investigating, where we do not get any responses over TCP, but I believe that's something else going on there. So our vote would be for something which is at least 1400. Having said that, I think, as Paul Hoffman just said, it may be impossible to recommend a single value in the RFC. So maybe saying a legal range as the recommendation may be the way to go. Say, do not set it less than this and do not set it higher than this, based on reasoning, and then leave it up to the operator.
Yep. Thank you. Jim Reed, please go ahead.
I think Puneet's just summed up what I wanted to say. It's probably impossible to converge on a single value for the payload size, which will satisfy every consideration in every scenario. And I think we shouldn't even try to do that. So my preference would be to set suggestions for a minimum value and an upper value with explanations why those values were chosen, and then leave some general guidelines for operators to say somewhere inside this mix might be the right value for you, and these are possibly the factors you should consider when trying to choose that. But I think trying to have the working group come up with an absolute number which will solve every problem for everybody is intractable. And one other thing I would just say is this document has been going on for quite some time in the DNS working group, and it must be really frustrating for Fujiwara-san that we still can't get some progress with it. I really think we should try to get this document completed and out the door.
I agree, indeed. So yeah, I will ask that first, the queue, and then I will come back to that later. Peter, please go ahead.
Hello.
Thank you, Jim.
As a resolver implementer, I don't have time to probe any numbers. So 1232 has worked well for us. It's worked well for many of our customers over the last 10 years. A resolver does not have time to probe. If a server doesn't answer, we cannot spend many more queries and seconds figuring out why that happens, trying different sizes, etc. Even worse, as a responder, one of the first slides suggested I probe the MPU path size to my clients, but I have no way to do that either. A responder does not remember a query it already answered. So to me, those parts of the draft are not implementable. Thank you.
Okay. Thank you. Other people, comments, questions, feedback? No? Okay, good. Thank you, Fujiwara-san. Indeed, so the thing is, what is necessary to go to make progress on the document? So an interval has been suggested for the default maximum size, payload size. You got some feedback from the implementers. But also, indeed, also in the working group, as a working group, comment, give feedback on the mailing list, and identify what has to be done, what is not possible, so we can make progress with the document and going towards working group last call. if it's ready, of course. Suzanne, you...
Yeah, just I think the thing that we would like to see more discussion, on the mailing list. How much can we agree on what to say about payload size, and what other content for this document do we think should be an RFC, and can we get consensus? Because I think what the chairs have to do is figure out where the consensus, how big the consensus really is, and how much of the draft it really covers. Thank you.
Thank you. Yeah. And I think we have good feedback from the room now to make a next version, and let's see how we can go forward and get consensus on these changes.
Thank you.
Yeah, please go ahead, Fujiwara. Fujiwara-san, you want to ask the room something specific or some final remarks?
Please review and comment.
Yeah, indeed. Please read the document, review the document, send comments to the mailing list. Yeah, thank you. Okay.
Thank you.
Go to the next slide set, and that's Wes. Wes, I can run the slides. What do you prefer?
I can do it either way.
Yeah, excellent. I'll give you grant screen, and I will stop sharing. You see the pop-up permission?
Let me try it again with, it says I have asked, but I don't see.
Okay, I will do it again. Yeah, okay.
There we go.
Yeah, I clicked, but not too early. Yeah, too early.
All right,
excellent.
Not a problem. So this is a document that I wrote a couple of weeks ago. Victor Duchovny and I are co-authors on it. I should have put his name on the slide. We've been talking about it for a while, and it seemed sort of finally the right time to throw it forward. So I won't go over the outline, that's boring. Real quick, just iterations refresher on how NSEC3 works. NSEC3 is an alternate proof of non-existence. I think most people in this room knows this. Its purpose is really to discourage zone enumeration and to provide an opt-out convention for large and unsigned, zones. And it does this by, instead of using clear text names in NSEC records, there's a start and an end domain name. The NSEC3 record it hashes that using n iterations of a cryptographic hash, where n is defined by the zone owner. And it allows the use of an optional salt as well in order to make offline dictionary attacks harder. So a couple of quick notes, and a lot of people forget this, is that the fully qualified domain name is actually put into the hash. So all of these offline dictionaries can't be built in a generic one that'll apply to the entire internet. The hashing is very zone specific. And the other thing to note is that rotating salts really only help once, because once you actually know that a name exists in a zone, you can just keep querying for it. You don't need to actually rotating the salt won't help you in the future. So it only helps the first attack, basically. The guidance in RFC 5155 sets these limits. So, and they sort of tie together the RSA key size and the strength of an RSA key to the number of iterations that they suggest if you want to try and, force attackers that are trying to do zone enumeration to really, come up with some pain, right? So the number of iterations gets larger as you use a potentially larger key, up to 2,500. And again, this is a maximum size. This is not a recommendation. So why is this a problem? Well, iterations are really expensive. They're complex for the authoritative engines to calculate. They're complex for the validators to calculate. And in the end result, everybody suffers. And as DNSSEC validation kind of increases in use, which is definitely happening, right? So there's sort of this thinking of maybe it's time to reduce these penalties. It's actually not helping people as much as it could be. And I know the NSEC3 authors are likely in the room. I would love their opinions on all of this as well. So it's time to define some sort of more reasonable limits given, our experience in deployment now. But, of course, there is no perfect, so everybody gets to choose their own values. So the proposal that we put into this document is a couple of things. One, we have recommendations for zone publishers that has an iterations count of 0 being, the recommended value, which really means 1 hash, right? So there's no additional hashing that goes on. So 0 does not mean 0. It really means 1. We recommend an empty salt value. If you're not going to rotate your salts, then don't use one. It just really doesn't help you. If you're going to rotate your salts, then feel free to go ahead and use one. And then again, opt-out should really be for large sparse zones. That's not terribly new, but we leave it in there as a recommendation for when you should turn on that bit. We also have recommendations for when for validating resolvers. And this is a lot of the new stuff of you should limit NSEC3 iterations to a maximum of 100. You should return a serve fail for unsupported sizes. So if somebody wants 101 and you're validating resolver, then you should return serve fail. And then we added a new EDE code to return an error so that you can more appropriately describe why you're returning a serve fail. I know that the serve fail is likely probably one of the more argumentative pieces of this document. I'll come back to that in a minute. None of this is cast in stone as the way forward, of course. That's up to the working group. So, the old table, the values on the left, and we're basically saying cap everything at 100. So what's next? And this is where the rest of the 15 minutes comes forward. There's really, 2 important questions to ask. One is this document, or this tasking something that the working group is going to consider adopting? Clearly, again, the details are going to be hammered out on the list. So whether or not you like serve fail or not is probably a different question to that of, is this a problem to be solved? And, is this a recognizable problem? And then, of course, what is the right track? It's actually, I think the first version I published was a BCP. Note that we're putting some shoulds and other things in there, and it really is updating 5155. So it seems to me like a standards track is probably the right way to go. Informational is even thrown around at one point. So with that, that's the end of my slides, and I'll turn it over to the chairs for a discussion of is this something we want to adopt?
Thank you. Thank you, Wes. Well, before we ask that question, let's first go to the queue. Roy, the floor is yours. Please go ahead.
Thank you, Benno, and thank you, Wes. So a few minor things and a big thing. From Victor Duchovny's statistics, and I think you've seen them as well. There are about 14 million, if not more, signed zones, and the bulk of them, about 75%, is signed with NSEC3. So any change with regards to NSEC3 iterations value is going to potentially impact a fair amount of signed zones. You also say let's reduce penalties, and then you talk about serve fail. I'm all about lowering the cap. I agree that it's not complex but costly, right? It's costly for the resolver and for the authoritative server. I'm happy to go with 100. Happy to go even with 25. My issue is with serve fail, and you probably know this. With RC 5155, we already have a solution for values that are above the cap, and we treat the zone as unsigned. Even if an algorithm is not supported, we treat the zone as unsigned. And if a diecast is not reported, we treat the zone as unsigned. So this is nothing new. So if an iterations value is unsupported, we should treat the zone as unsigned. I'm happy for the current cap to be lowered, such as like I said before, 25. I just can't support serve fail. With regards to the other things, I think reducing the cap is the most important part of a potential working group adopted draft. I think there's a slight misunderstanding, or maybe a slightly we could clarify the purpose of SALT a little bit better. I just think it's a distraction from all of this. So I wouldn't even discuss SALT. Wouldn't even discuss opt-out. It's not a BCP. I think it's a standards track if you want to lower the cap value. Anyway, good work. As you know, we've talked about this before, and it's just I rather have insecure rather than serve fail. Thanks, Wes.
Sure. Thanks, Roy. And there is a question of, do we want to narrowly scope it down to one thing? I think some additional guidance on reasonable SALT values and when to do things operationally, might be needed. The opt-out is really already in 5155, so if it becomes standard to track, that probably is out of place and it's no longer looking BCP-like. Thanks, Roy.
Sorry. Jim, please go ahead.
Wes, you're on the right track here. I think there's a good case to be made for some implementation guidelines or deployment guidelines around this stuff. The one thing I would say is that the number 100 sounds a little bit arbitrary to me, and I wonder if you've got any data to back that up. Or maybe we could even use a lower limit on the number of iterations. And,
yeah,
if we have to gather data, perhaps we could get that from some of the big resolver operators, because surely they can tell us how often they're seeing these resource records in the wild. And maybe we could get the SALT value down to something even lower. I'm very, very worried about this, and always have been since NSEC 3 was first suggested, because of the implication it has for the validating resolvers. You could do nasty denial of service attacks by having huge values for those salts, or the iterations on the salts.
Thanks, Jim. I don't think that, I believe somebody out there actually has numbers for how long it takes a CPU to actually calculate, n iterations of SHAs for NSEC 3 specific records. That work has been done. I don't have those numbers. Victor Duchovny's and my project on stats.dnsectools.org, we do have a list of all of the zones that exist out there that we know of with NSEC 3 parameters and the sizes that they're using. So we do have information about that. Whether 100 is the right value or not is, to me, that's sort of a reasonable balance of not ridiculously high and yet, still provide some people some room. And that is a somewhat reasonable cutoff. Victor can share those numbers at some point in the future.
Okay, sorry. Thank you. Peter Thomason.
Yeah. Thunderstorm here. I hope you're not disturbed by the thunder. Anyways, and the sun shining at the same time is weird. I have a question or a comment about the SALT question or the SALT issue. So I do follow Wes's argument that if the zone name is baked into the full name is baked into the hash, then there is no reason to have a SALT, because salts are to prevent creating a rainbow table, which is mitigated anyways. And I have not heard whether there's any other arguments from anyone for keeping a SALT. So if there's any proponents, I'd be interested in what the pros would be.
Well, I think if you are adding new names, or if you have a highly dynamic zone where you're adding and removing names on a regular basis, then it prevents, it allows more computations for as people are changing from one set of dictionaries to attack to, or one set of zone data to attack to the next one, that they can't just keep reusing the same thing, and they end up having to, recalculate a bunch of names to see if let's say you have a name called login.example.com, right? And it doesn't exist today, and you've actually calculated the value with the SALT that was in use. Well, if the SALT changes, then you have to go recalculate that entire hash for the next zone where you're looking to and waiting for it to appear. So there is some benefit to it if you're going to rotate it. If you're not going to rotate it, then it really doesn't help you.
Got it.
Okay.
Right.
Yeah, there are no other people in the queue. Then we come. Oh, Ulrich. Go ahead. We have time.
Sorry, last second hop in here.
Okay.
I wanted to ask, have you any stats about how many domains would actually hit by if we cut off at 100?
Yes, as I mentioned earlier, Victor has a good list of domains. Certainly it's impossible to query the entire planet, but he has a fairly extensive list of what domains out there are deploying what values. So we have that list available to us. I don't have the numbers in my head for where the percentage cutoffs are, but one of the reasons that 100 was picked was because of looking at that list and where people were cutting off and falling off. So.
Okay. Jim, please go ahead.
Pedro, what's the next steps? Are you going to issue a call for adoption?
Yeah, that was my next step. Yeah, but
Well, that would be down on the list. So.
Yeah, of course. So I think, well, again, the feedback on the mailing list, or here in the room, sorry. Lieber, I will come back to you in 10 seconds. I think that's positive. Working group adoption, we take it also to the list, of course, to the mailing list. With the authors and the co-chairs will schedule that so that there are not more than one working group adoption a week or something like that is running. But I think the feedback from the room is good, it's positive, and I also reading the chat that this kind of guidelines for implementers is also very useful. So indeed, thanks. Libor, please.
Sorry for joining the last second. Just my opinion on the number of iterations is that, yeah, I very much welcome the new recommended value to be around 0 or 1. But I think that the most important is the absolute maximum capping, because, well, this is about security of both the authoritative and the recursive resolvers. And if the attacker wants to, like, denial of service attack some recursive resolver, it's up to him how he chooses this iteration value. So he can simply craft NSX zone and choose the maximum number of iterations and perform this attack. So I would be even glad if we consider lowering this maximum value, which is now expected at 100 to much lower, like 10 or something really very low, because it's about security of the resolvers. And that's all. Thanks.
Okay, thanks. Yeah, I saw a raised hand by Roy, but disappeared again. Okay, I think thank you for the discussion. We take it to the mailing list, and we also will issue a working group adoption call for adoption on the mailing list.
We'll try and get a CDF curve posted to the list for where the cutoffs lie and what fraction of the existing world are we cutting off by going to 100. We'll post that to the mailing list.
Yeah.
Great. Okay. Thank you.
Thank you. Okay. Right. Okay. Next up is Ulrich Wisser. Ulrich, do you want to run your slides your own, or shall I share them?
You can share the slides, please.
Yeah. Okay. And application window. Yeah. There we are. Share. And there we are. Okay, please go ahead.
Yes. Okay. So, hello, I'm Ulrich from the Swedish Internet Foundation. And so we are running a project together with Steve Crocker and Schumann invited us to be part of a project about multi-signer. And you might remember Schumann's RFC about the multi-signer DNSSEC models a few years back. And I have to share a little secret with you. When Schumann came first with this RFC, I looked at it and I thought, okay, there's literally 5 people on the planet who are going to run this. Who is ever going to need multi-signer? And then when we got invited to this project, it turns out that if you want to change name server operators without going insecure, that is exactly what you need to do. So changing name server operators means you join in a multi-signer group, and then the old operator leaves the multi-signer group. So basically everybody with a DNSSEC signed domain is going to want to do this at one point in time. So you know how this goes with these only 5 people on the planet predictions. Yeah, I made one of these. So what are we working on? We want to, let's say, the whole algorithm for changing name server operators for a DNSSEC signed domain is quite complex. And I think most people here in the room will come up with the correct algorithm. and we all have to think a little bit about the timing and things, but we all have to, give it a good thought, and it's not just something we do on the side. And so it means it's a really complex operation, and that means that a lot of system administrators out there will have problems running it correctly. And so I think this is something that really should be automated. And so we looked at the how to automate this, and and luckily there is a CDS CDNS key, and then there is the csync record, and with these we can actually automate the whole process actually without involving going to the registrar, giving passing keys along the line, and you all know the problems we have with this. So this makes the whole thing solvable from a pure DNS perspective. And that is what we're trying to do. We have written here a new draft, and we have started describing the algorithm. And this is very much a work in progress. So we really would like you all to take a good look at it and come up with, see what we're missing, or if we did get any of the timing wrong and things like that. So we really appreciate help. And next slide, please. Yes. And so how would you run this? Well, in the multi-signer DNSSEC models that Schumann described, there's this, there's a description of an API. And so with that, you would have a centralized version of the multi-signer controller. You would control the whole multi-signer setup from a centralized software, maybe. And it would communicate with all the signers involved through an API. And we actually have implemented this with DESEC, and we tried this with PowerDNS through their web API, and this actually works. And at this point, I was going to say that PowerDNS doesn't support csync, and we're waiting on Peter to implement, to merge. But obviously, he knew that I was going to say this and merged it today. So we're going to try this next week with even with csync and PowerDNS. We actually tried to do it through dynamic updates, but it turns out that none of the name server softwares available would accept a dynamic update, a DNS key record in dynamic update, or CDS CDNS key record in the dynamic update. So this is not going to work that way, or we have to work out something. And then there is the, let's say, a decentralized model that we would say, and that were that the involved signers, name server software, would talk to each other, would collect the information needed, and would then publish that information. And for that, obviously, we would need to define some protocol elements in the future. So next slide, please. Yes, so we are looking for feedback on the document, and we would really like to come in contact with implementers and see if we can make the whole operation easier, because I can say that we didn't even manage to get it working with command line tools. And I got help from Mark Andrews, and I'm still struggling with it. So it's not that easy. And so, yeah, and that's, I hope for feedback, ideas, and comments. Thank you.
Thank you, Ulrich. Jonathan, please go ahead.
Hey, John Reed, Akamai. I thank you for this work. This is definitely an area where we need something. We had the RFCs about best practices, but this is a bit more practical. That's great. One of the challenges that I see in this is it's talking about the ZSK, and what we do, and I don't know if the providers do this, but what our customers like is very frequent rotations of the ZSK and infrequent rotations of the KSK, which is part of the point of the KSK. And some guidance in here about whether or not it is advisable to pause ZSK rotations during this process, or what would be some guidance there would be helpful. The other thing is we also see customers who are so hesitant to make any DS updates that in their registrar, even for KSK rotations. So part of the challenge, I think, is establishing some best practices about how long this multi-signer group should exist. Obviously, it need to exist for as long as it's practical, but having some guidelines around how long this should take and best practices for that would be helpful. I'm sure there's an argument to be made that those things don't necessarily belong in that draft, but I think from my perspective, they would be helpful.
Yes, so just so the how long the I can speak to the last point first, and that is how long the transition should take. I think that is more a question of TTLs. I mean, you have to, the parent has to pick up the new DS set, and then you have to wait before you can start to update the NS set. But once the parent has updated the NS set, then you can start to do the whole thing again and try to push out the old. So I think the process will not be fast, but it is very dependent on TTLs in the zones and how often, for example, the parent would do the CDS and CSync scanning. Right now, I know only about on the Swiss.ch and the Czech.cz that do the scanning at all, and they do it once a day. So it is not immediate.
Yeah, I meant more having an upper bound, not a lower bound, because I've seen this process take months, and
Yeah,
Thanks.
no, of course, yes.
Okay, good. Other questions, feedback, suggestions? See, there's also a good discussion on the Jabber. So going once, going twice. No. Thank you, Ulrich. Looking forward to the next version of the draft, and probably in July we'll see an update of the draft and the presentation from you.
Yes, absolutely, and we're going to present a lot of this and more practical work we did at the ICANN DNSSEC workshop.
Okay, excellent. Good.
Thank you.
And thank you. Bye. And then next is sorry, I have to check my agenda. Next is I think Neil Cook will give the presentation. Is that correct? DNS access denied error page. Neil, there you are. Do you want to run the slides, or shall I share them?
You can run them. There's only like 4 slides or something.
Yeah, I will do that. Yes. Okay, there we are.
Okay, so this is really about just addressing the feedback in the last interim session. So I'm not going to cover like what it does, just the comments that were given to us since then. So go to the next slide. Just to recap what this is basically an error page URI, excuse me, that you can send as a DNS resolver in conjunction with the various filtered error codes, or the error codes, extended error codes, which are related to filtering, to give users more information about why something was filtered. So there were 2 main comments raised by the working group. So one is, why not use the extra text field to communicate this that's already in EDE? And the second one is, well, why do you have a signature field in the option? So I'll just cover these on the next couple of slides. So next slide. So the extra text field in extended error codes, is not authenticated, so it can be spoofed. There's no way to display anything in a language which obviously you can do with the URI, because web pages you can give people the language that they want. It displays the source of the error, not necessarily the cause of the error. So it's essentially not practical for what we want to do. The idea behind this is that we give a URI, which then can have a web page, which is easily renderable by a user, or by a user's browser or whatever, and can actually display useful information potentially in multiple languages. So that's why extra text isn't suitable for this. I don't know if anyone has any comments on that before I move on.
Next slide.
Yeah, next slide.
Okay.
The next comment was about, well, why do we have a signature? Well, clearly the URI template that we pass back in this could be spoofed, right? So we mandate that it has to be propagated and processed over an authenticated and encrypted connection. So that's really important. But you also want to make sure that this is what the resolver wanted to give you, the thing that you're talking to wanted to give you, that it trusts it, and not something that it receives from downstream, which might have been, or upstream, whichever way you look at it, which might have been subject to an attack. So what we do is we say, well, no matter where it came from, the thing that you're talking to has to validate that what it's got, whether it's generated itself, which is fine, or if it's got it from somewhere else, it has to validate that it trusts that, and then either generate the signature itself or regenerate the signature if it came from somewhere else. So, and essentially that signature is then signed in the same way, so with the key that you've used for TLS, so that you can verify the signature. So the idea behind this is then if the signature validation fails, then you don't go to an insecure page which may have been created by an attacker, which you definitely don't want to do. So that's the reason for the signature, so that you can essentially validate that this URI this URI template is actually something that you want to go to, and it can be trusted. So the idea is, if the resolver that you're talking to trusts it, then you can trust it. Yeah, next slide. And so obviously we specify that if something's forwarding this and doesn't recognize it, so a forwarder forwards it onto something which then gives it to the client, obviously the signature is not going to be correct, because the forwarder hasn't generated the signature. So the signature has to be generated by the thing that you're talking to, and not something sort of downstream from that. So that's the idea. These are the only two comments that I think that are relevant. So I'd be interested if there's anything else on this draft. Yeah. I think Ben has a comment.
So on the signature, I'm a little confused. What name is the client validating the signature against? Every DNSX signature is for a domain name.
Well, it's essentially using the same keying material that's being used for TLS.
But if I'm okay. So if I remember right, a previous version of this draft specified that the error page had to be served from the same TLS authority as the DNS connection was using. So if I was connected to, if I have an encrypted DNS connection to some DNS server that I know by its name, then I can just check that the URL uses the same domain name. Is that?
No, I think that's changed, because we don't want it necessarily. You could go to another. We don't want to restrict it to necessarily the same domain name.
So, okay, I think it's important to restrict it to the same domain name. Not only because it drastically simplifies this question of trying to figure out whether you're talking to the right party, but also because if we can substitute any domain name, then we reopen a vast array of questions around the potential for phishing. I can direct the user to an error page that clones facebook.com and uses a domain name that closely resembles facebook.com. So I think that we should stick with that model. But to step back one level here, I think for this draft to make progress, we really need to see some client-side implementer interest. And really, I think that it shouldn't, in terms of working group adoption, I think that it shouldn't be adopted unless basically we can find a co-author who essentially represents the client-side implementation interest or has deep knowledge of that. Because the proposals here for security, to do this securely on the client, require tremendously invasive, really almost re-architecture of the browser security model. It requires an entirely new concept of an isolated page in ways that couple into W3C specifications about how web pages interact. So I think the level of complexity is a little bit out of control, and I haven't seen really any confirmed interest there.
Okay, I think Tira has his co-author. I think he has some comments on that. But in general, I agree. Sorry.
Yeah, so Ben, to address your comments, right? Well, the first one was related to what if you get a phishing page, right? So the draft takes the principle in the draft uses techniques similar to what we see in Captive Portal, that that page is treated as an untrusted page and displayed in an isolated environment without any user input. So that's one way to prevent that attacks. And the signature is basically generated by the TLS server certificate's private key. So the client would know that it's actually coming from the DNS resolver and not from anybody else upstream, or it doesn't understand the option and just is sending the option. So it's actually providing data origin authentication that it's actually coming from the TLS server that it is talking to.
I guess Ben's point is that you may trust this DNS server for DNS requests, but you may not trust it to send you to a web page. Right? I guess that's the point you're making there, Ben.
Yeah, and I also, on that signature scheme specifically, I want to comment that the server-side implementation difficulty of this is also kind of huge. There are many cases where the server operator literally has no way to satisfy this requirement because the TLS front-end serving infrastructure is thoroughly decoupled from the DNS answer generation.
Yeah, that's a good point, Ben. So if you see the draft, it's just the URI template, and the signature is a static signature. So it doesn't change with every domain. So it's a fixed data over which the signature is generated. So even in case of TLS traffic offloading, the signature is not going to change for every domain that is getting blocked.
So I can understand. I understand what you're saying here, but it still assumes that the signer has access to the TLS private key in order to generate contents that show up in the DNS data stream.
It necessarily does not have to. For example, if there is a load balancer which is doing TLS offloading, those signatures can be generated by the backend server and handed over to the front end server. So it's just a static piece of configuration.
Yes, but it at a minimum requires a new kind of communication between the entity that holds your TLS private key that's being used for the session and the DNS generation.
Yeah.
But I think probably more importantly from Ben's comments is getting someone on the client side interested in this, because I think we can kind of tease out more of these issues if we have got someone from one of the browser vendors, for example, who's interested in co-authoring this or contributing to this. So.
Okay. Thank you. Any other comments? Questions? No. Yeah. So back to the last slide. Indeed, consider working group adoption. I think, given the feedback and comments from Ben, and I understand this. You're already on version 6, so it takes already some time. But I rather have further discussion on these issues than we start a working group adoption. I feel it's too early for this call to the working group. And also, there hasn't been at the start there was some discussion on the mailing list, but I haven't checked recently. But I think in the last month or maybe half year, there was not much discussion on the draft. So also the working group involvement should really increase here. And I think, given the suggestions from Ben and the feedback, I'm looking forward to the next version and increased working group involvement in the discussion. Do you have some other questions, remarks to the chairs or to the working group?
I think one of the potential issues is that this is of interest to people potentially who running who create browsers or whatever, or people who run who run systems doing filtering so they can have a better user experience. And I don't know how much overlap there is with DNSOP in those people. So that could be one reason for the lack of comments on this draft and potentially interest in it.
Okay, that's a good point. So maybe also the chairs can discuss this with you and with the authors to find another audience, maybe, or a second audience to discuss this.
Yeah, I think it's important to get multiple groups looking at this. This is not purely the DNSOP thing. And we've been getting better at being able to coordinate with chairs of other working groups and so on. But this does need the broader review.
Yeah. Thank you. So Neil and Turi, we will get in contact with you how to proceed and find another or a second audience to review or to read and review the document. Okay, thank you. Let's see. Next up is Roy, if I'm correct. Again, I can't see my agenda, but I have everything sorted out.
Yep, that's right.
Yeah, indeed. Yeah. Excellent. Roy is already there. I will share my screen.
All right, I've got a whopping amount of slides, and I'll let you. I'll let you go through it. You give it away. All right.
Yeah. There we are. Okay.
So there's two parts to this. Sorry, go ahead, guys.
The floor is yours. Please go ahead, Roy. Yeah.
Thank you, Benno, Suzanne, and Tim. I'll first give you a recap what I'm talking about, what we've been doing since the last IETF 109, and the second slide will be about what is hopefully going to happen. So what I'm talking about, draft errands, DNS error reporting. I happen to be a co-author. My other co-author is Matt Larson. The idea is basically that DNS resolvers, when they encounter an error, instead of just burying the error in the log, they can maybe communicate this with the owner of that domain that's failing, or the operator of the authoritative server. And the draft describes a method on how to do this. And This was first communicated a while back to a few colleagues who actually write DNS software, who know more about DNS operations than I ever would, who have large customer bases, etc., etc. And they didn't immediately run away screaming, so which is a good sign. So I call that overall positive. Then I asked during the last IETF's Hackathon 109 if some folks would like to implement this. We have one implementation. The server side is implemented, and just as a proof of concept. Nothing is in stable code or anything. So with a proof of concept implementation on the server side, the resolver side basically depends on extended DNS error implementations. Yeah, we're waiting for that as well. The current draft is fairly mature. You will see some additional edits in version 1, but the idea seems stable. Next slide, please, Benno. Thank you. So a few things happened in the last couple of weeks. I noticed some issues with DS records at the zone apex. I never thought that this was implementable, but actually you see it happen. So this is a failure that could potentially be reported. Wes spoke earlier about NSEC 3 iterations higher than the cap that's recommended in RFC 5155, or to potentially lower that cap and go with Surfill. This Surfill can then be reported with a signal that's in DNS Error Reporting. We know of many DNSSEC configuration issues. I've put a few on the slide, a few top-level domains, but also a few second-level domains that I happen to know of that had some configuration issues. Recently, we had, I'm not going to say anything wrong here, but I think one of the root server implementations that had a slightly wrong response. Those things can all be reported to the appropriate operator or owner of the zone. Then a colleague of mine, Paul Hoffman, he mentioned that recent work in the deep-dive working group, they have proposed using DNS records for discovery of if an authoritative server offers DNS over encrypted transport. Now, when that happens, it would be useful for Resolver to report if such a discovery ends in an error. And this method that is in our draft can deliver that error basically. Meanwhile, also since last IETF, I've sent a message to the IETF DNS operations working group chairs, Benno, Suzanne, and Tim, if they were interested in asking the working group if there's consensus. Benno was kind enough to invite me to give a presentation on this. This is that presentation. So my question to the IETF DNS operations work group chairs is, would you be ready to ask for consensus on the mailing list? So that's it for my presentation.
Thank you, Roy.
Yep.
Any comments before I start? Before I will answer your question. Okay, good. Paul, please go ahead.
Just very briefly, Roy said the bit that I wanted to about deprive. So as we are discussing in deprive, the fact that in the DNS you can say, I've got an authoritative server, multiple people who were skeptical of that said, well, we would need to have a way of telling an authoritative server that they should be doing it because they're announcing it. And this would be super lightweight. I don't want to see deprive doing basically the moral equivalent of this just for our own work. I think that having a general one would be good. Thanks.
Thank you. Puneet, please go ahead.
Hi, Roy. So this sounds quite interesting from a practical perspective to report errors. But one question I have, which I couldn't get the answer from the security considerations section, is this is going over an unencrypted transport. And what is there to prevent abusive players on the internet from just trashing this endpoint with garbage data.
All right. So the idea is basically if the error came from a domain that was retrieved over an encrypted channel, then the reporting should be over an encrypted channel. So you preserve privacy. That's the general idea. That might not be reflected in the current draft, but it will be in the next one. There is nothing that anyone can do to anyone to stop anyone from sending anything over the internet. This is the golden rule. So if people want to trash this, they can. If people want to send traffic, they can. The most they would get out of it is that they would send an error report to some domain owner who can then immediately see that that either there is an error and acts upon it, or can just ignore it. So there's no real cryptographic authentication, if you will, or cryptographic foundation. It's just a lightweight reporting method, a ping, if you will, if that makes any sense.
So, Roy, I think I probably exaggerated when I said trash, but in the sense that some malicious but smart adversary could send you data which looks plausible, but then requires you to end up spending a lot of cycles of operators to investigate, right? That's my concern here, that the signal to noise ratio may go down if we don't have some way of saying this is good data.
No, I agree, and but if this would be done in practice, I think, for instance, if there's a small misconfiguration in www.example.com where one image hosted on image.example.com fails validation, then the entire world will start reporting. So you know in your signals, if 40 million Elvis fans, they can be wrong, right? So if the entire world suddenly starts from different locations start reporting an error, something is going on, probably a misconfiguration. Now, if you happen to operate a banking domain, right, and you see from somewhere unsavory that errors are happening, then you might actually be seeing a validation failure, or someone is trying to spoof a DNS cache, which is interesting information in itself. This all allows you to report it. And yes, of course, you need to investigate. And the moment you investigate, there might be false errors. I completely see that.
Yeah. Thank you. Sorry, Brett, please go ahead.
Read the draft, Roy, but I just wanted to add my support, because I think that anything that allows operators to do more in-depth and easier troubleshooting than we have currently is to be encouraged and applauded.
Cool, thank you, Brett.
Okay, thanks. Next in queue is Jim Reed.
I agree with what Brett has just said. If we can get more information out to people to help them troubleshoot problems, that's a great idea. I do think, though, we need to think a little bit more about the threat models and the risks, some of the concerns that Puneet alluded to a moment or two ago. And I think some of his concerns are valid, but some of them maybe not so much. Because after all, we have the same problem just now, even with DNSSEC. We can't validate if a serve failed or a refused or a not implemented error code response is genuine or not. So we can't necessarily guarantee that other error failure modes are going to be telling the truth, the whole truth, and nothing but the truth. And I think we just have to live with that. So I think we have to accept that as an ugly compromise, and then figure out how we can improve the overall ecosystem by at least providing some information that can be helpful, but at the same time being mindful of the risks and threats that might introduce.
Jim, if I may respond to that. Yes, I think you're right. And the other option is to have a completely secure way of doing things, which in itself has new failure modes, which in itself needs yet another way of signaling, which needs to have new failure modes. And you get into this endless, heavy, complex loop that is completely unavoidable if you just keep it lightweight. And of course, I'm hand waving now. I completely understand that.
Yeah.
Thanks, Jim.
I am in violent agreement with you, Roy, and that's a deeply troubling thing.
Cheers, Jim. I owe you a beer.
Yeah. Thanks. Next in queue is Ben Schwartz.
Hey, support. I think we should adopt and make this real. As a number of people have said in the chat, I wonder if you could restrict this to TCP or DNS cookies, or basically some mechanism like source IP validation.
Yeah.
Yep, that sounds good. That sounds good. As long as it's lightweight, I don't think it's too much overhead to ask for a TCP. As long as the failure mode, the fall off, would be would be small.
Yeah.
Thanks, Ben.
Thanks. Matt, please go ahead. Next is Matt. Matt Pouncett.
Apologies.
No problem.
Yeah, two different mute buttons that I have to maintain. I just wanted to add a bit to what Puneet said. So as an operator, I find the idea of this interesting, but my mind immediately goes to, I'm going to receive hundreds of thousands of error reports every hour, and I'm never going to be able to look at them. I'm never going to know which ones are real things that I should investigate and which ones are people just messing with the system. So I wonder how many people would actually implement this. That said, though, I could see it being useful in a situation where you can set up some sort of bilateral agreement to accept those error reports, maybe TSIG authentication or something like that. So yeah, it seems interesting and worth exploring, but I have some concerns.
Thanks, Matt. If I can respond to that, the part of the idea is that the authoritative server would send in an EDNS 0 option a location where to report this thing. So in a sense, that's an opt-in, right? You basically opt in on the authoritative server side. You're basically saying by publishing this EDNS 0 option, I would like to see errors if you have any. Mm-hmm. So that's part of the idea.
Right, but then having published that endpoint, I expect to see error reports that aren't error reports, and I expect to see them in extremely high volume.
Yes.
Like what I'm saying is I expect to see an incredibly high volume of noise, so much as to make it useless, unless I can restrict somehow who's able to actually send stuff to that endpoint.
Yeah, no, I understand.
Yeah.
I understand. So everyone, these are all good comments, and I would like to have them on the list as well. My brain is a sieve often, so like Teflon, nothing sticks.
We do have the recording, so you can listen
brilliant.
back. Yeah. Good. Peter Thomas, please go ahead.
So as you just heard, there is the need to have some kind of tooling on the auth side to do, or the domain owner side to do the aggregation of whatever the number of error reports is, and then to interpret them. And it's similar like with DMARC, as somebody in the chat mentioned, even though probably the DMARC volume is lower than DNS query volume. What I was wondering is if I go through the failure modes that are listed on the slides that are currently being shared, so NSEC configuration, DNSSEC stuff, whether some deprive thing is set, and all this, those are things that follow from the zone contents themselves, or maybe in conjunction with the DS records in the parent, and they don't in particular have anything to do with the specific resolver setup. At least it doesn't seem to be the case for me. So while the error would probably come to the surface at resolving time, the error should also be, if it's this kind of error that is shown on the slide, it should also be detectable by just looking at the zone file, which of course doing requires extra tooling on on the auth side, but the same is true for interpreting this kind of error, except that there is a lot of a much higher number of parties involved and a much higher number of reports involved. So why not develop great tooling for the auth side to interpret zones and figure out the same kinds of errors without doing all this involving everybody thing?
I completely agree, and Brad can confirm this. If we had all the tools available to test all the value modes that would ever exist now and in the future, then we wouldn't have to check this on the resolver side. But when I was working at Nominet, we had everything perfect, everything done, and still we introduced previously revoked key in the DNS for, I think, .uk at the time. And of course, we did this on a Friday. And yes, we had all the tooling to test all this stuff. Most of the tooling were built in-house. Some of the tooling were for third parties, but we couldn't just foresee this one. And I mean, if we could, we would have done it. So we were basically reported this error via Twitter by one of our colleagues, and it was fairly embarrassing. Now, if I would have this error report like 5 seconds after I published the record, because someone in I don't know, West Samoa would try to resolve it and fails, and then send me an error report, I could do something immediately. And this is not an either-or thing. You're right. These things need to be checked the moment you publish. But there's always the potential to overlook things, always. And I've learned it the hard way. And I'm sure some of you have as well. And so I think it's good if this is done in the resolver as well.
Okay.
But thanks for the comment.
I have one small follow-up. In the SA record, there is the email address for the zone admin. Is that where things are supposed to go? I don't think so, right? Because why not?
No, there's nothing to do with an email address. The whole idea is that in the EDNS 0, in the EDNS 0 option, there is a suffix, if you will, that you apply to the owner name that you just tried to resolve that failed. And the details are in the draft, but no, this is not sending an email. This is just sending another DNS record off, just sending another query off.
Okay, I wasn't aware of the method. Okay, cool.
Thank you. Well, good discussion, and we do have time. But let's close the queue now. Paul, please go ahead.
Whoops, sorry. I saw that Warren was in front of me. So to go back
sorry. Okay.
Well, he was, but then he wasn't. So
yeah.
To go back to Matt's concern of I'm going to get flooded and I'm not going to be able to deal with the flood. One of the things in this draft that I really like is the fact that the authoritative, give the prefix of where to send this to. So you can change that in your EDNS option as often as you want. So in a sense, this is somewhat like salting, but if you want to, if you want to change that every 5 minutes, you can change where it gets sent to. And so it's not like that once you have published something, it's going, like once you've published an address equivalent, that it's going to get spammed forever. Because as soon as you stop publishing that, you can stop looking at it. Thanks.
Thank you. Alex, please go ahead.
Yeah, thank you. Roy, thanks for getting this together, and I think it's pretty interesting. However, I also understand the concern of being like spammed with false error reports, and one way around this, besides the thing that Paul mentioned, which doesn't really help you because that only means that you get the spam to a new address every 5 minutes in the first place. But anyways, it doesn't really prevent anybody to send you spam. What about adding text to the draft that I'm trying to phrase it very carefully, puts higher level of trust into reports that arrive via protocols that are harder to spoof. Specifically, if I get an error reporting via an encrypted DNS connection from a client, then it's probably more trustworthy than and query that I get in what TCP port 53 UDP from a non-existing, non-routed IP address. Let me put it that way. Yeah, I know it's like opening a can of worms, but that might be an option. I think this is useful because it's a little bit like DMARC essentially. Yeah, that has proven to be useful in some scenarios as well.
Yeah, I think it's actually exactly like DMARC. That's where the idea stems from. Initially, when I heard about DMARC, I thought that yeah, no one's going to report stuff, and everyone is reporting, so that's great. It works. There are organizations around this that help brands to just make sure that they're stable, and this is actually the missing link that I thought between operators of resolvers and operator authoritative domains. Now, with regards to the reporting itself, keep in mind that since this is not a query, you can actually, on the response to the error, you can set a timer, you can set a TTL of basically 1 hour or 1 day, and you're supposed to cache that locally. So there's some management that you can do as well. If you overload it with errors, take the EDN0 option out, right? That's also an option. You don't really have to change it. You could change it every 5 minutes, but there are various methods of doing things. The reason this is so, the reason I think this needs to be lightweight and not having a slightly more complex mode using HTTP or email or whatever, is that all of these other methods, the moment you step out of the protocol, you will introduce new failure modes. And you get into this loop again. So I just want to avoid all the additional complexity and start simple. But yeah, once this thing is adopted, it's out of my hands, of course, and then it's a working group's problem to solve, basically. But thanks for your comment, Alex.
Respond to that because I didn't mean to step outside of the DNS protocol. I only meant that as an operator of an DNS server that receives reports, I would probably consider reports that come in via TCP or DOT to be more trustworthy than random TCP reports. That's what I meant. I didn't mean to step into HTTP or email or whatever. I meant to let them.
Yeah, sorry. No, I get what you mean.
Protocol family. Yeah.
Okay.
Yeah. No, you're absolutely right. I misunderstood. I apologize. So, yeah,
thank you, Roy.
You're right.
Yep. I think we have a good idea of the room. It's positive. So back to your last question or last bullet point, not a question. We will coordinate a working group call for adoption of this draft later in the next weeks. But we will contact you and Matt, the authors of the draft. Thank you, Roy. Good. Then we come to the next presentation of for Jari. Great. Jari, shall I run the slides? What do you prefer?
Yes, please.
Yeah. Before Jari gets started with this, the chair has actually talked with the DNSOP chair has actually talked with Jari and with the ADD and deprive chairs about where this draft might find a home. We haven't taken a position on whether DNSOP is the home, but we did feel that DNSOP has the widest range of people who would be interested and would have an opinion on where this draft should go next. So we're not necessarily looking at this for adoption, but we are looking for whether people are interested in further consideration and doing work on it.
Yeah.
Thank you, Jari.
Thank you. And we are looking for feedback. So this is a topic that me and some of my colleagues and students looked at. We have a problem that we think is important and some directions for a solution. And we're here to talk about that a little bit and see if you think this is perhaps workable, or you have concerns, or this is old news, or too much science fiction. So let's see. Next slide, please. Yeah, so I need to set the context a little bit. So obviously, DNS privacy is popular, and we've had issues with things being visible on the wire. We've had issues with things being visible in the servers and leaking from there. And of course, the resolver services can be an attractive target for, let's say, governments or attackers or so on to retrieve some information about people's browsing histories, for instance, because they do see the browsing history. And as a result of this, we've seen obviously some work in IETF and elsewhere. We've worked on encrypted DNS query protocols, which plugs the hole on the communication security side of things. We've seen discovery work at ADD. And the idea there is that we can turn on the encryption in a wider number of cases and maybe also distribute the queries to more places, not to concentrate too much in one place. We've also seen like the RFC on recommended practices, how to run some of these services, what to do with logging and so on. We've also seen expectations and contracts by people like the Mozilla Foundation, who's trusted recursive resolver requirements, set some guidelines on what needs to be done. And of course, we also had improvements outside DNS, ESNI, and so on. And then sort of totally outside these arrangements, there's also some general technology developments, and some of which we plan to use here, confidential computing in particular. Next slide, please. And so the idea here for us has been that we should build on all of that work and assume that we actually have taken all of these steps that we've been planning and building technology for. So for instance, that all the communications are encrypted. And the question then is, what's the remaining problem or problems, and is there a next step? And our main worry is that the resolvers can be a major remaining source of leaks through accidents, attacks, commercial use, requests by authorities. And I know none of us makes mistakes, but they can still happen. And the thing is that we actually need to protect the user's data in flight, in the communications time, but also at rest or in use. And what we wanted to do is to figure out if we could actually do something with this confidential computing stuff to reduce the leaks on the latter too. And there are some possibilities, but they come with some impacts, some operational impacts that might be worth discussing in this working group in particular. And one way to see what we're trying to do here is that you could potentially implement like a technical version of some of these resolver requirements or things that people publish on the websites or make contracts out of, but to actually check some of that. Next slide, please. So I'm not going to go into too much of the details. I think many of you know the basic things, but this is basically about using these trusted execution environments or TEEs. And so that's ability to create these processes inside computers that are entirely encrypted, even when they write to local memory and so on. You can't actually see what's going on. Even the operating system or the owner of the computer can't see that. And there's also some capabilities to provide attestations, even to remote parties, which is about, verifiable statement that this is a process run in this kind of an arrangement and environment, and it uses this particular software image. So a basic idea is that we run the resolver process inside TEE and don't actually provide any user-specific data outside this encrypted process. So we, on purpose, like if we're the DNS operator, we cut ourselves out of the stream of data relating to user-relatable events, at least. And the same is true of the owner of the computer hardware, if that's different from the DNS operator if you run in the cloud, and the operating system, of course, as well. And of course, this requires somebody willing to provide these services in this manner. And depending a little bit how you do this, you might also require to trust a third party for some aspects with regards to, is this a CPU that's using some of these technologies, and did we manufacture that CPU, and what is a good software or good software image that is trustworthy, and so on. But you don't absolutely have to do that unless you really want to. Next slide, please. So the basic arrangement is that everything about the client's process of asking about a particular name is inside the encrypted platform. So it's encrypted, first of all, for the transport part of it, and the transport ends inside this encrypted TEE. It doesn't leave that. Of course, the resolver that answers a query may, in some cases, need to consult the rest of the internet, and there's some discussion in the draft about how one can do that securely. But basically, the information about who asked for what is kept inside. So in this sense, this is kind of similar to oblivious DNS in that it tries to keep away the information of which client asked for what. Next slide, please. Okay, so now we get to the interesting piece. So that previous stuff was basically just the setup that, okay, we can maybe do this, and at least in theory it seems possible, but the question is, can we do this in practice? And this is in particular where I would like to get your feedback. So obviously the upside is that it's possible to hide all user-related information, and we actually argue that one should do so because it's simply good management of data that you constrain who has access to data, and there's no reason for most of the parts of the process, at least, to have access to that data. It's just something that the user needs. And another upside is that we could provide evidence. We don't have to, but we could have the clients actually do something extra. They could do a verification. They could do a remote attestation of the service, which of course would require some changes to the clients, which is a big hurdle. But this is in theory possible. Trust but verify. Do we like this service, but I actually want to trust that they actually do what they advertise? The downsides relate to operational practices. So obviously, you need to have a big service. You want to do scaling, systems monitoring, debugging. You need to be able to respond to denial of service attacks and so on. The way that we saw this in our experiments was that we can address them, at least to an extent. So the goal here is that we shouldn't reveal the individual user behavior, that Jari asked for this name, but we could still reveal aggregate statistics on, what's the load on this instance, what's the performance, memory, cache, error counts for different types of situations. We can set limits on particular types of requests or from particular clients or networks, and perhaps even control that dynamically from outside. Next slide. It also brings to my mind that sometimes we actually use the data in some way. So some parties actually use the data for sort of business purposes. And of course, if you intentionally forget user-related stuff, then you can't sell the user's browsing history anywhere. Okay, but I think that's a good thing. But you could still take the aggregatable data. So you could have like a top 100 of this kind lists and so on that you could gather. You could also gather not just for like names and so on, but you could also understand like what are the biggest memory consumers or error cases and so on, in order to understand if there's something fundamentally wrong with the software. You could also do additional functions like geolocation or some other things that somebody wants to do, as long as you do it inside the TEE, because no data, user relatable data leaves that, so that should be fine. There's also dependencies, another downside. So you need suitable server hardware. I think that's largely available, and some of the cloud providers are also providing these services nowadays. Use of attestation leads to the need to have this trusted party that you can go and ask, let's say the CPU manufacturer, that is this good CPU, and do they actually execute in this manner that they claim? You might need separately also somebody who says that this software image is good. We verified it. We looked at the open source, having compiled it, and this is the image hash, and it's good. It doesn't leak user information according to our analysis. But if you have the clients do something extra, of course, that requires changes in the clients, which may or may not be feasible in some cases. And sort of the main conclusion of all of this is that this is, we think, interesting and could provide more evidence of actually protecting the user's data. It's not a cure for all problems, and there are issues that, of course, remain. If you thought a manufacturer's CPU was secure, you are not well informed. There are attacks. There's also side channel attacks that you can use to determine things. You can have software problems still, even if your software is securely run. But it will still provide an additional layer of defense. So for instance, from the point of view of pervasive monitoring, that some agency tries to look at all the user's data in a particular DNS provider or operator. And now they would have to go through this as well. I mean, of course, we do believe that some attacks are possible against these types of setups, but now they would actually have to do it in order to gain this information, whereas previously all they needed to do is to have, say root access on the machine. Next slide, please. So I will leave it at that. The only conclusion that I want to say here is that I think we really need to look carefully at the data held by the servers, and we should look at security of that as much as we look at the communications. It's particularly crucial for DNS. We should consider all the tools. This is one particular tool. Like to hear if you think this is, tried and found wanting, or something interesting but with concerns, or perhaps total science fiction and not feasible. So with that, I'll end and expect some comments. Thank you.
Oh, thank you, Jari. We have a queue. Thank you for your presentation. Very interesting. Sorry, Warren, please go ahead.
Thanks. So yeah, Warren Kamari with No Hats. Yeah, this does seem really interesting, but something that I think needs a bit more discussion is the sort of remote attestation part. Like, how do I actually know that this really is executing in some sort of enclave? The draft sort of mentions there'll be an attestation, but doesn't really cover how. And without that, I don't really see how this is different to, a third party saying you're querying a server, in which case you could just say you're querying a server that doesn't log anything.
Right, and the reason that I didn't include that part in the draft was that that's sort of covered extensively by others. But it is true, though, of course, that is something that does require. We need to understand that in order to evaluate things like this. But there are, for instance, IETF working groups working on this. They have a particular approach. There are other designs, and there's a fair number of variants and architectures, and that would require another discussion. There's also protocol details, exactly how you transport. This is like a certificate extension.
Yeah, you need a way.
There's lots of opportunities.
Yeah.
Thank you,
So,
Benjamin. Yeah.
Hi, Ben Schwartz. I'm very excited about this concept. And yes, one of the interesting challenges is that the remote attestation, the CPU can prove to you that AMD claims that its chip is running software with a particular hash, but you need reproducible builds, and every client needs to know the hashes of all of its trusted software builds, or you need a trust infrastructure where somebody checks those hashes against the reproducible build of something. That's one of many challenges here. Nonetheless, I think this is great stuff. Maybe the right approach here would be a non-working group forming BOF, because really this is highly speculative. It's I think many years away from DNS operational practice. It's fairly close to the privacy research group, PAIRG, that might not be a bad place to talk about these things. And I think it will require us to give a lot of thought to the exact threat models and kinds of guarantees we want. For example, one model I've considered here is a cache-only resolver. So you send your queries, and if the queries are in cache, you get a response back. It's all perfectly confidential. If the response is not in cache, you get an error back, and you have to go fetch it yourself and understand that you've lost your confidentiality guarantee, because otherwise it's very unclear what the confidentiality guarantee is of a thing that's actually forwarding your query on to some third system. So there's many architectures. It's speculative, but this is something I'm very excited about, and I'd love to find a way to support.
Thank you. And you suggested this possible both idea. One other idea might also be that this is maybe more implementation. And I mean, there's obviously a protocol component also, but maybe that's a small piece compared to the sort of building the software and so on. And I think we might actually consider also some, I don't know, interop or open source project or some such in this space. So maybe next hackathon might be a good moment for that. And the other comment that I wanted to make is that you mentioned about the privacy of thing that forwards questions, and that can be handled in multiple ways. As you mentioned, the cache only option, but there's also other options. What we actually did in our experiment was that we check the cache and then we return an answer. And if we don't have the thing in the cache, then we do have to ask somebody else. But we also we confuse the timing, whether or not we use the cache. We always randomize the timing. And so if you get 1,000 queries into the box, and then all the time you also get let's say 500 queries out of the box, but you can't actually match at least not exactly this came in and then 1 nanosecond later a query was sent out. That's not the case with the kind of arrangement that we're doing, but there's lots of algorithms that one could imagine here. So room for research also.
Thank you. I'm closing the queue, so Jim is the last, and well, please keep it a bit brief because we have still one presentation. Thanks. Sarah, you're next.
Hi, this is just a comment related to the suggestion of bringing it to PERG. I think as one of the PERG chairs, I think we'd certainly be interested in what we could do to host this and help it evolve initially, and just be the list where you could get some of that feedback actively. So be happy to talk about that offline.
Okay, great, thank you.
This is Daniel Kahn-Gilmore. I am excited about the thought of trying to think about how much information is held by a server and how to ensure that the server is protecting that information. I am pretty dubious about the trusted execution environment approach. There's a lot of ways that information can radiate from a server that's making these replies. And so you could imagine the information radiates because maybe the service is choosing the wrong ephemeral secrets for the transport session, for example. And then the data could be held not by the server that's running the well-trusted code, but by some additional network device that happens to have a tap into the communication. So that's not to say that I think that the goal is wrong, but I think that the TEE, there's a lot of wiggle room, and it'd be very difficult to figure out how to pin that down accurately.
Yeah, I don't disagree. Certainly, a lot to look at.
Yeah, this is Jim. I agree. There's a lot to look at here, and it's not just going to be on the engineering side. There's also a lot of policy considerations and stuff. I think also the cost-benefit analysis of this approach will be fascinating and perhaps take a long time to clarify or crystallize. I think, though, that in terms of an IETF home for this working group, DNSOP might be the best choice or the least bad choice for it, because this topic, I think, is going to run for several years and might well outlast PERG or DPRIVE. And since DNOP is the working group that never dies, this might be the best place as a home for it, and obviously can be built from there and moved out into other working groups and BOFs as and when is appropriate. But I think this might be the right shelter to start this work off, Yari.
Thank you.
Yeah. Okay. Yeah. Thank you. Jari, you want to answer something?
No, I think I'm done, and you had something else, Tilton.
No, excellent. Thank you. Thank you for the presentation, and we will follow up and also discuss with the other DNS related chairs, working groups, what's the best home for the presentation, for the draft. We go to the last presentation. Let's see. Michael, thank you. You're already there. Shall I run the slides?
Let me.
Yeah, please go ahead. I will give you.
There
Your
window. There we go. Okay. Hi. So I'm here to talk about MUD and DNS and IoT. We all love to talk about IoT devices. There. I'm sorry, I've actually missed the IETF part in the title, but it's in the minutes correctly. So what's the problem that I'm here to talk about? Well, we have this lovely thing, RFC 8520, manufacturer usage description. If you haven't checked it out, please, it's a kind of very sweet little protocol from Elliot Lear. Basically it describes a set of network ACLs, which I now learn I'm supposed to pronounce that way. In Yang, they're serialized to JSON and they're signed with CMS. And the idea is that the device says, I am a foo kind of device. The ACLs say these are what a legitimate connections are, and if this device does something else, then there's probably a problem. And so there's a lot of people quite excited this, particularly in the enterprise space, particularly in health, where they have hundreds and some thousands of devices and they don't even know where they are sometimes. And they really would like to get a handle on what kind of network traffic is legitimate and not legitimate. So, but we'd like to use DNS in these ACLs, and this can present challenges. And so first I'm going to explain how not to do it. And I'm sure to you guys, this is the DNS op, this is totally obvious, but the part of the point of this document is it's not obvious to many of the people that this document is targeted at. So you need to do a forward lookup, right? Or do you? So people think, okay, I see the packet. There's some source and destination addresses. I'll look up the IP address with that reverse map, right, to get a name, and then I'll compare that to my ACL. Will that work, right? Well, that's a total fail, and there's a whole bunch of reasons for this. You can't do it fast enough. There aren't really any reliable reverse names. There's all sorts of things why this doesn't work. So don't do that. That's part of the beginning of this document to say this. Okay, so you need to do it the other way. Only do forward lookups. So you start from the MUD file. Okay, you do the access, you do the DNS lookups on the names, and you get an address. And that's what you write into your fib policy, the positive parts that say, okay, I found this name, it maps to this thing, and that's what I put into my firewall rule. So then I got to make sure I do this right. So I got to respect the TTL. I got to make sure that I'm getting the same address that the device is going to look up. And then we need to worry about DNS over HTTP or QUIC or TLS along the way as well. And this document is essentially about. So in the best scenario, in a home network, everything, all of these components happen in the same thing. Your MUD controller lives inside your home router, and it consults the DNS cache that is on the home router, and it does the DNS lookups, and the device does DNS lookups to the home router. So this has been, the kind of typical situation until 5 or 6 years ago. We couldn't have imagined anything else that way. And so now things have changed, and so this is partly about what has changed. Okay, it is more complicated in enterprises, and there's a lot of people who want to use various bits of SDN to do this. And so this document is a little bit about, well, how do you do that? And this is where I'd really like a fair bit of review and feedback as to whether I'm getting all the things right. So the document deals with how you should implement this, how not to do the things that we have in the second slide, and how not to leak the queries, and why you want to do this. So I would love to have some feedback from this group as to what parts I've missed there. One of the things that I believe that I have correct, but I may just not be operationally out there, is the business of round-robin DNS and geofence DNS. My understanding is that, for instance, that when you do round-robin DNS, that you're supposed to get back the list of all of the A records and quad A records. Of course, they don't all fit in the packet, and that's part of the problem. But that you're supposed to use the first one, and that what's supposed to happen is that it just rotates which one is the first one. That's historically what happened. And if you do that, and that's how it's organized, then it's fine, because the MUD controller gets the list of all possible answers, can put them all into the forwarding the ACL, and then the device, when it later gets one, it gets whichever one it thinks is the right one, and everything's good. And as long as things don't change faster than the TTL, then I think this works fine. The issue is that I think that in many cases there are more A and quad A records than are returned. And I think that in the geofence space, that of course you don't get all of the names for all of the world. But the hope is that if you can use the right DNS cache, and you can convince all the devices to use the same DNS cache as the MUD controller, then you may get a consistent answer back from things, and life will be good. Ben Schwartz has some comments to the list this week that this may not be all good, and I'd like to know if there are any solutions to this, or whether essentially we're going to have to guess and deal with what we think is there. So one of the pieces of advice to IoT devices specifically is to use the DNS provided by DHCP, whether that's DO53 or DOH or DOT or whatever, but you should use that one and not some other random one you found on the internet that you think may be more secure. And ideally, that manufacturers, when they're dealing with their devices, are going to call back typically to them, that they make sure that they are not overloading that round-robin answer, and that they're actually able to return all the records, because MUD requires some effort by the manufacturer, and so they would probably like it to work. So there's my joke for that. So that's really it. That's my question. And did I get some things wrong? And we discussed this in AD at one point. It's not appropriate for there. It now has a home in Ops AWG, which is the home for MUD. So there's not asking you to adopt it. I'm asking you to please review it and tell me where I've gone wrong. Maybe there's one more slide. Yeah. Ben, you're in the queue.
Hi. So I don't need to repeat my email. On your previous slide, I want to say I have learned through my time here that RR sets in the DNS are strictly unordered sets. There's no such thing as the first element in the set. And that at least if systems are conformant, there is no such thing as part of the set. Sets are atomic. So
yes, okay. That's good to know.
The authoritative server can give different sets to different people. So the actual domain owner may be handing out different sets of IP addresses to every time somebody asks. Each of those sets is an atomic unit that shouldn't subsequently be modified. But if you ask certainly through two different resolvers, you'll get two different answers. Even if you ask twice through the same resolver, you can certainly get two different answers, unless it so happens that the result you wanted is still in cache.
Right.
And it's not sufficient for it to have recently been queried. That's no guarantee that it's in cache, because caches have eviction. So, so even if the TTL hasn't expired, that record could have been evicted from the cache.
So when preparing this document, I went back and found some RFCs that explained round-robin DNS, and a lot of the lore was actually not in a standard. And I believe that back at the dawn of the web browser, that there was a belief that you could send back a ordered set, and that the browser was likely to use the first one, and that's how you accomplished both fault tolerance. They would get a set of addresses that they could try, but that they were likely you would steer them to the one that you wanted to by putting that first. And you're telling me that that's never really worked and never really been a there.
So there are other people here who can answer that more authoritatively. But the bottom line is that your resolver is within its rights to shuffle those.
Yeah. And that's actually okay, because I don't care about the ordering of it. As long as I get the complete set, I'm happy, because I assume that that's going to happen. And that's why I went back to read that, to say, okay, well, what's going on? I said, okay, so it's not that they're returning one answer and ignoring the rest. They're supposed to return all of the answers. And the hint was the first one is the one to use, but not everyone did that.
Yeah,
I think material. So yeah, beyond that, I'll just say I'll stick to the email, and we should follow up there.
Thanks for that email too, James, Ben. Peter.
Yeah.
Peter.
I queued 3 times, and then Ben said what I wanted to say, so I dequeued. But just to the last bit, when you said to Ben, so you're telling me this was never true. The things you're saying about round robin, trying the first address, etc., they have always been statistically true. But this is not good enough for you.
I don't care if it's the first one. I'm not the web service trying to direct you to a particular server, right?
No.
I went back to look at that to see what was happening in that space. And at the time, that's what people were believing. But they said, but you always return the entire set of all the addresses, because that's what I really cared about, was that you would always get the whole set because of that. And what Ben said about cache eviction policy is absolutely true. And I think that's one of the challenges and implementation challenges, and partly why we'd really like the IoT device to use a DNS server that is under the control of the MUD system, such that we can either be aware and override the cache eviction policy, or we can do something intelligent to knowing when, if there's a requery, we can see the requery and know what happened that way.
Thanks. Michael, you're running your own time, or you're managing your own time now, because you also want to pitch your BOF.
Yeah, so let me do that then.
Peter and Benjamin on queue. But again, you're in charge now. We have 4 minutes. Yeah.
Well, why don't you ask your question while I switch the slide?
Yeah. Are there any questions still?
Ben Schwartz. So this isn't a question, but I'll just say I think that this draft has hit upon a real problem, but I don't think it can be solved with operational considerations. I think that MUD DNS is basically slightly misspecified, or at least specified in an unclear way, where the logical interpretation, the intuitive interpretation is wrong. So
well, and I want to follow up with that on the list, Ben.
I think we should solve it.
Very well taken. So tomorrow morning, this is an unrelated thing, to make a clear brag. I don't have a hat to change here. Wes and I are co-chairing a BOF called Danish. I can't get the acronym right, so I won't even try. But it's about Dane, and it's about IoT security hardening. That's the ISH. But I can't remember how the DAN works now. But anyway, it's tomorrow morning in room 8, first thing. It's going to be discussing these three drafts and discussing the problem space for these 3 drafts. Click on the right thing. This is a bit about our agenda, so you can see where we're going. We're really trying to figure out if we understand what the problem space is, and to understand what problem we're trying to solve here. And there's been a lot of interest over many years in coming back to Dane to do things. And it looks like that IoT, there are a number of IoT vendors that think that this may actually help them a great deal. And so there's where it's coming from. So this is the thing. Come if you can, watch the video if you can't, join the mailing list. And that's again some of the goals. Part of the goal is to be able to support object security as well as session security for this. So that may be something that some of you are interested in if you want to see your non-DNS queries get across the network without being seen. Thank you. Paul, you had a question.
Very quick question, because I know we're out of time. Is that supposed to be working group forming or just discussion off?
Non-working group forming this time. We are we are closer to working group forming now than we were when the BOF was requested, but we are not going to be wordsmithing a charter at the meeting tomorrow. So you won't miss that if that matters to you. Thanks. Thank you all for your time.
Yeah, I think we're done. Unless Benno or Tim had anything else to add. In particular, these last two drafts, Yari's and Michael's, it's really helpful to even for work that we don't anticipate will happen in DNSOP, or drafts that we don't anticipate will be adopted here. It's really helpful to people sometimes to have the feedback from the DNS operations experts. So thanks everybody that's commented on those. And if you want to comment and haven't, please feel free to reach across and provide some cross-area review for those documents. And I think that is the end of DNSOP for IETF 110, unless Benno has something to add, or Tim, hi guys. Nope. It's not at all clear whether there'll be a in-person IETF next time or not, but in any case, there will be an IETF 111, and we'll see everybody there one way or another. Thanks for your time.
Thank you. Thank you all. Bye.